All right, so mother trucker homework. That's right. I named it that. We're sketching the path that the left and right mirrors take. Left mirror is going to take something like that. We'll call that left. And if we're looking at the right mirror, oops, why is that not green? Right. It's going to do something like this. And then next we're supposed to draw what the blocks of ice do. So I'm going to do this big block of ice. That's right, I sneezed in the middle of that video. You still have to watch it. Suck it up, Buttercup. All right, so blue one's going to pretty much go straight, and it's going to want to go straight until it hits the side of that side of the car. Because if there's no friction, it's going to try and go in a straight line for as long as possible. And then this smaller red one is going to do exactly the same thing. It's just going to have to start doing the turn a little bit earlier because it hits the wall. It's already right up against the wall, so it's going to start turning much closer to the same time that the rest of the thing does. So that's my little. That's it. Then friend who's not physics class, say they go to the outside of the truck because of centrifugal force. No, your friend's so dumb. The reason why this happens is, again, Newton's first law. They want to go straight, which basically leads to them hitting the side of the truck as the truck's turning because it gets in the way. So it only is an apparent force that pushes them towards the outside of the truck. It's really just an object in motion staying in motion. Okay, then it approaches another intersection, talking about static friction. It wants to know why static friction, not kinetic friction, is on the truck. Oh, that's easy. It's because wheels don't slip. If you're making, don't slips. If you're making a turn and you're not losing control of your vehicle, then the wheels are staying in contact with the road in a static manner. They're not spinning relative to the road. Okay. Then explain what happens to the truck if the value of mvr squared. Mvr squared can be thought of as the needed force. Like you need that much force to make the turn. Whereas, is it mu mg? My picture's in the way. Oh, just mu fn. Mu fn can be thought of as the available force. So mu fn is how much force friction can do. Mv squared is how much it needs to make the turn. So if mv squared is bigger than mu fn, then that car is not making the turn. That car is going to either start to slide, or it's just not going to make the turn as sharp as it needed to in order to make that turn. And then which turn, left or right, requires the truck to slow down more. You guys should be writing this as a paragraph to practice that paragraph writing skill that you need for your exam. But as the quick video version, the right-hand turn has a lower R value, which means they need to take it slower in order to keep the total quantity of mv squared the same. For the bigger turn, since you have a bigger R, you can do it at a higher speed and still keep the mv squared over R quotient the same value. So something to that effect is what we were looking for on that one. And that's it. Now I'm stopping the video. And you're still watching because it takes Screencastify a long time for me to, there we go.